Good day, everyone. So I'm here to continue the electron displacement methods. So in my previous class, I've explained the inductive effect and I've explained electromeric effect. And mesomeric what effect. If you could still remember what electromeric effect I said is a permanent effect. Electromeric effect is a temporary effect. Mesomeric effect is also a permanent effect, like inductive. And this inductive effect, it takes place on a sigma bond. The electromagnetic effect takes place on a what? On a pi what? Pi bond. Mesomeric effect also takes place on a what? On a pi bond. But the inductive effect is the uneven distribution of the sigma bond electron. Uneven distribution of sigma bond electron in two elements of different electronegativity, like we have carbon and what? And chlorine here in organic compound. This chlorine is more electronegative than what? The carbon. So the bond electron here will shift toward the what? Toward the chlorine. This is what we call what? Inductive effect. As a result of the shifting of this sigma bond electron toward the chlorine become partial positive negative charge, carbon become partial negative charge. This is what we call what? Inductive effect. Is the shifting of the pi sigma bond electron to the element of higher electronegativity. And don't forget, in that video, I said this inductive effect can be grouped into two. We have what we call positive I effect, and we have what we call what? Negative I what? I effect. This positive I effect, I said they are electron releasing or electron donating. Example, here we have a key group. A key what? A key group. This common example for electron withdrawing group, I use halogen. And I give you several examples on it. And there are others of inductivities. If you are talking of what? Electromagnetic effect. The electromagnetic effect is the shifting of pi bond what? Electron. This is a carbon bond. This first bond here is sigma. This one is pi. So the shifting of this pi bond electron into one of these two carbon due to the presence of external what? External reagents in it. So when this external reagent is what? Is present here, what happens? This pi bond electron will shift to this side. So you will now have what? Carbon, negative. Here we have positive. Because the bond electron shift to this side. This is what we call one inductive what? Electromagnetic effect. Shifting of the pi bond electron in the absence of what? Of absent the presence of what? Of reagent. So this mesomeric is the also a shifting of what? Of We have a carbonic group. Shifting of this is sigma bond, this is a pi bond. Shifting of this pi bond to this oxygen. Why? The oxygen is more electronegative than what the carbon. So this shifting of the pi bond electron into the element of higher electronegativity is what we call mesomeric what? Effect. In the absence of what? Of the what? Attacking the agent. So this is what? Here we have plus. This is meso what? Mesomeric effect. That's where we stop in the previous class. And I said mesomeric effect divided into two parts. We have positive. We have positive M effect, and we have what? Negative M what? M effect. What are the positive M effects? They are electron releasing. Example of this positive M effect, I give halogen, fluorine, chlorine, bromine, iodine. They are positive what? M what? M effect. And yes, and we also have an amine is also what? A positive what? M what? M a what? Effect. They release electron. They are electron releasing or donating. But in this case, yeah, negative what? M effect, they are electron what? Withdrawing. They withdraw what? Electron. This one. An example of this one we have N what? NO2, and we have alkyl what? Group. Check my previous video on what? On inductive, electromeric, and mesomeric. But today, class, I would like to continue the mesomeric effect by treating the application of metomeric what? Mesomeric effect. Start from the application of mesomeric effect, WPRV. Application of mesomeric what? Effect. What are the application of mesomeric effect? If we look at mesomeric effect, the first application of mesomeric effect is used to determine molecular stability. What did I say? You can use it to what? To determine what? What? How am I going to spell it molecular? Molecular stability of compound. Molecular what? Stability of what? Of compound. That is, let me put it this way. That is used to determine stability of aromatic compound. Aromatic what? Compound. So that's the first what? That's the first application of what? Mesomeric effect. You can also use mesomeric effect to determine the variation of acidity and the basicity of some compounds. Yes. Number two, for what? Determine the variation or the acidity of, okay, can you tell me the what? Acid what? Acidity. Acidi, eh, acidity of phenol. Yes, the acidity of phenol and carboxylic acid. Cyclic what? Acid can be determined by what? by mesomeric what? Effect. We can use mesomeric effect to determine the acidity of phenol and carboxylic what? Carboxylic acid. Hmm. 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 Yes. Look at it. The negative M effect group. What? Negative what? M. Let me explain this. The negative what? M effect group, like NO2, increase C's acidity of mm, yes, acidity of benzoic acid. Benzoic what? Uh, benzoic acid. Mhm. By stabilizing. Yes, stabilizing the conjugate base in it. Let's look at this illustration. Say what? You can use what? The mesomeric effect to determine the acidity of phenol and the carboxylic what? Acid. So I say what kind of mesomeric effect affects the acidity of carboxylic acid? Is what? M effect, not is negative M effect, not positive M what? Effect. In this now illustration, look at the example here. Okay, for example, for what? For example, look at this example here. If I said what? Acidity of substituted, substituted benzoic acid. Substitute what? Benzoic acid of NO2 C6H4 COOH. Yes, is more acidic. Yes, than is more acidic than methyl C6H4 COOH. Why? Due to negative effect. Due to what? Negative what? Effect of NO2. See what I'm trying to explain here. This. Okay. If you are asked, I said negative M what? Effect. Yeah. No, I said negative M what? Effect is one that affects the acidity of benzoic acid. So we are given two compounds there. What is the first compound we have here? We are given what? NO2 C6 H what? H4 COOH. If you look at this compound, the structure for this compound is this. Let me draw it out. The structure for this compound is with this. This is benzene. Here is what? Benzene. We have the benzene structure in this form. Can you see it? Here's the benzoic acid. On top of it, we have what? COOH. This is it. We have a benzene in there. This one is what? NO2. Look at the second compound. We are given what? We are given methyl CH3 C6H4 COOH. So if we look at this compound, is we have benzene in this form. This is what? COOH. This methyl is here. If you look at this thing, this NO here, the presence of what? Of NO what? Here is an electron what? Withdrawing what? Group. So this thing is undergo what we call what? Negative what? M effect. And this alkyl group is positive what? M what? M effect. And the presence of what? Of this NO in acid here. What happened to it? You know, is what? It will take out the what? The electron from benzoic what? Acid. It's like I've explained the sketch under example of negative M what? Effect. So the taking out of electron from the what? From benzoic acid, it will make it easier for this hydrogen to be what? To ionize, according to the Arrhenius concept of what? Of acid. But this alkyl group, they are electron what? Releasing. So when this alkyl group is what? Is releasing electron to what? To what is it? Is releasing electron to benzoic acid. It will make it difficult for the benzoic acid to ionize this hydrogen. As a result of that, it will reduce the what? The acidity. So this man is more acidic than what? Than this. So that is what? The reason. The next one is basicity of a man. You can also use mesomeric effect also affect the what? The basicity. Basicity of what? Of a man. If you look at the basicity of a man, here, let me give you this, look at this example. The example of aniline. Yes, it's less acidic than ammonia. Yes, example, for example, what? Aniline. What is aniline? Is amine, the benzene amine, C6H5NH2. This is aniline. Benzene amine is less what? Acidic. Sorry, is less than basic than ammonia. Why? Because mhm, because the lone pairs on nitrogen on what? Nitrogen is delocalized. The what? Delocalized into the so negative M effect reduce the availability of what? The electron. Let's look at it now. We have this aniline C6H5NH2. This is the symbol. We have benzene ring NH what? 2. So, and compare it with what? Ammonia Na3. We are now asked which of the two is more acidic. So, because of the presence of what? Aniline we have here, this one is an uh, electron withdrawing what? Group. So, the aniline we have here is serve as what? Negative M what? Effect. M what? Effect. The presence of it will reduce the what? The acidity. As a result of that, this ammonia, sorry, excuse me. This ammonia is more basic than what? The aniline. So the presence of M, negative M effect reduce the basicity. The presence of what? Negative M effect in benzoic acid is increase the acidity. But let me add this again. Note, we have some functional group that exhibit both mesomeric effect and inductive effect. What are the functional group? The only functional group that undergo what? Both mesomeric effect and inductive effect they used to have. They are what? They are halogen. They are what? Halogen, which is what? Fluorine. We have chlorine, bromine, and what? And iodine. All this family, they undergo what? They undergo what we call negative iot effects in a compound. This same family also undergo positive M what effect in a what? In the structure. I explained it in last class. Let me add it again. Take for example, if you have what? A compound in this form. Assume this is compound is what? Is benzene. We have this. At this end here, we now have what? Let me use fluorine. This end here, we have fluorine that's attached to it. And this fluorine that's attached to it, we have it has its own what? Lone pair. Three what? Lone pair. Abi? And between this fluorine, between this what? Fluorine and this what? Benzene. You know, this is benzene. Abi? Between this chlorine and benzene, this is the sigma what? Sigma bond. The benzene fluorine here is uh, hmm, the fluorine here is what? Is withdraw or attracting electron to himself. The electron is what? Is going to the what? To this chlorine to himself through the what? Negative inductive what? Effect. And this same chlorine again can also release this lone pair electron into this bond. Ready? When a case this lone pair electron to this one will also what? Move towards to this side. As a result of that, this structure we have it in this form. Our benzene ring will look like what? This here that is this come to. We have negative here. We have double bond here, double bond here. So here we now have what? Double bond flow what? Fluorine. We have double what? Double bond what? Flow what? Fluorine. Mhm. Out of the lone pair we have here, when we have lone pair here, out of the lone pair we have here, we have what? One, two, three. This abuse, you put what? Plus here. Have you know? And the ability of this fluorine to release this lone pair into the aromatic range, you know, it is what we call what? We call it what? Positive a what? Effect. You can see that is what? In this chlorine alone, by releasing the what? The lone pair of electron into the aromatic ring is called positive M effect. By attracting or shifting the pi bond electron here, sigma bond electron toward himself is called negative inductive effect. So all halogen family undergo this kind of what? Effect. So that is all about mesomeric what? Effect. Mesomeric effect is determine the stability, it is for the molecular stability of what? Of a compound. And we can use it for what? To determine the acidity of phenol and carboxylic what? Acid. Hey, acidity. If you have to what? To explain this, how can we use mesomeric effect to determine acidity of phenol? You know, we all know that phenol has this shape. It's benzene what? Hydroxy. Abi, it's benzene hydroxy. We have what? OH here. And this OH, OH is lone pair. So when this donate this lone pair here, this will also come here again. So by doing that, we are going to have what? This structure, we have it in this form. Here we have negative, this, we have this. This place will be what? OH, lone pair. We have plus here. And again, this one will come to this side, this will come to this side. So the next thing will give us what? This is the what? You have double bond there. This OH, lone pair, plus this one we have negative, we have positive here. So the next thing that will happen here is what? This will come to this side, and this will come to this side. This will come what? To what? To this side. We have it in this. This is it. We have it here. Here we have negative. We have what? OH. Have this. If this change come to this side, this bond will what? Will go to what? to this oxygen back. So we now have what? Mhm. Ah, so this is the effect. The OH here is negative M what? Effect is a releasing is a positive M what effect like what? Like fluorine here. So good. That is all about application of mesomeric effects. Let us move to the next factors that determine the electron displacement method.